everyone. Thank you for joining our CTC's broadcast of Spaces Above and Beyond with our presenter John Atkinson, an applications engineer from CTC. Before I hand it over to John, I just wanted to go over a couple of housekeeping guidelines, I guess. As you'll notice, everyone is muted. If you have a question, please put it in the chat queue or in the questions queue as well. The session is being recorded, and we will have a link posted to our YouTube site within the next couple of days. So I'll hand it over to John.
All right, thanks, Laura. So today we're talking about spaces above and beyond. This is for Revit and mainly for MEP. And I know most of you use spaces, not all of you, but typically I've been seeing people use spaces just to place mark and report and tag rooms. Well, the difference between rooms and spaces, rooms are basically architectural. They contain finish information. They've got some area and volume in them. But spaces contain all the information pertaining to the equipment that is located within them. It'll give us lighting loads, power loads, heating and cooling, and we can define the occupancy and construction types for those spaces. Now with lighting, spaces can calculate the average estimated illumination based on the light fixtures in them, and these rely on the photometrics based in the family for the initial intensity parameters, light loss factor. The space calculates its room cavity ratio, and then the light fixture also has a coefficient of utilization. One of the issues that I've noticed is that you must have an IES file associated to the light fixture in order for that to calculate something other than 0. And I'll show that here in just a minute. For mechanical, spaces can be used to report our supply and return air terminal CFMs. Our spaces have 3 parameters: for supply, return, and exhaust. These would be specified, so if you're looking for 1 CFM per square foot, just as a starting point, you can specify that. It'll also give us the actual reading off of the air terminals that we place within the space. And we can have calculated either based off of running the load calculations within Revit itself or exporting them out to train trace and back. The energy parameters for each space rely upon the conditions, the ASHRAE space type, construction type. I generally set this to code minimums. We can also read the information right out of the architectural walls and glazing based upon the U values that they specify. People, we can use either a calculated based off of that space type, or we can specify the number of people that are going to be within the space. We have our electrical loads, same thing, design, heating and cooling loads. We'll get into that in a little while. And then to go on top of our spaces, we can combine spaces into zones for our HVAC. And within those zones, we define our service type, our heating and cooling set points, humidification if you have it, and then outdoor air. So if you are running heating and cooling load calculations within Revit, we can actually get a fair amount of accuracy if we set it up properly. One of the things that it doesn't do very well is ASHRAE 62.1. because it uses the higher of the three values for CFM per person, CFM per square foot, or air exchanges, and whichever one returns the highest value is what you're going to get within your load calculations. So I typically go in and fudge my CFM per square foot by breaking it down. Like here I have an example of an office space. For this particular zone, it's 5 CFM per person, and under the space type, it requires 215.28 square feet per person. So if we divide that 5 CFM by 215, we get 0.023 CFM per square foot. And we add that on to, from the ASHRAE 62.1 table of 0.06 CFM per square foot, so we can fudge that into 0.083 CFM per square foot and come out with a very close CFM per square foot. We can also take our space and zone information and export that to Train Trace 700 or as a GBXML. Or we can also, there's any number of load calculation software out there, but to my knowledge, Trace is the only one that will bring those numbers back into Revit and populate your calculated values. So for me, the best practice I've found is to define our spaces and zones as accurately as possible, and also I push my spaces, I push that volume all the way up to the level above and make all of my ceilings non-room bounding. So a quick run through of the setup. We place our spaces in our model. We set our upper limit to level above at 0 feet 0 inches. We turn off the room boundings for our ceilings in the architectural model. We define our space type according to ASHRAE. Then we start creating our zones, then place our equipment, receptacles and whatnot, and then for design and coordination, we then create a bunch of space schedules and embed maybe air terminals or equipment or light fixtures to get a good feel of what we're looking at within the building itself. So with that, I'm going to jump into Revit here real quick. I've got a floor plan here. It's my power plan with one space kind of outlined. And as you can see, I've got it, my upper limit is set to roof with a 0 offset. And I do have some light fixtures in here, but it's not reading anything, and I'll walk through some of the information that we have to make sure our light fixtures have. We can also set our ceiling, floor, and wall reflectances based upon the finishes that the architect might tell us they have, or we can just leave them at some default. And we can put in required lighting loads. Now further down, excuse me, under our electrical loads, we have all of our different parameters based upon the load classification. So we have computer load for these 3 receptacles popping up at 540 VA. We have some lights that are showing up in the space. And we also have one receptacle down here in the bottom, giving us 180 VA. Now we've got area, an unbounded height, and then our volume. If you take 387 square feet divided by 12 foot 8 of the unbounded height, it's not, or multiplied by the unbounded height. It's not 3,100 cubic feet, and I'll show you why that is. Further down in our mechanical airflow, you can see we have a bunch of specified supply air calculated, and then our actual, which is reading off of a couple of air terminals that we have in the space. The nice thing about spaces is they know that there is, if you have your architectural model and they have rooms, it knows if there's something coincident. So this particular space knows that in the architectural model I have an office 106 in that space. I can kind of set this back to nothing, and one of the nice tools, you can run out to Autodesk, the App Store, and pick up the space naming utility for free, and that would be this guy right here. And you can quickly run this through your entire project and have it automatically run through and update and match what's going on with the architectural model. Now further down here under our energy analysis, we have plenum type and occupiable. If I'm running heating and cooling loads, exporting them to trace or using it within Revit, I will not use the plenum type space. It becomes really redundant, and the person doing the calculations within trace has to go through, delete all the plenum spaces, and push all the occupiable spaces up to that level above. Next, we can take our condition type. Is it heated or cooled? Unconditioned? Is it vented? And then our space type. These are all based off ASHRAE. And if we go down to office and closed for this particular one, I've got area per person, 215.28 square feet. We also have our sensible and latent heat gains, a calculated load, lighting load density and power load density. And these are fully customizable to your preferences. We can also look at the construction type and the U values specified for roofs, exterior walls, interior walls, and whatnot. Just a word about exterior walls. When Revit is making, if you're using the heating and cooling load calculations, if a space does not have a space on the other side of it, it is going to consider that wall, that partition, to be an exterior partition, and will apply the exterior walls accordingly. Same with glazing and whatnot. So make sure that your entire project is populated with spaces properly defined within the space type and construction type. And we can copy and edit these U values as needed to meet our code minimums. Now under people, we can come through and say occupancy is either calculated off of that space type, or we can specify it either by the actual number of people or the area per person. Same with heat gains, we can specify what those are. Either we can use the default calculated value or specify what those are going to be. Electrical loads, identical. We're pulling all this information out of our space type and having it automatically calculate for us what it is that we're going to be needing. Now you'll see under here calculated heating load and calculated cooling loads. They're not computed. I haven't run this through the heating and cooling load calculations yet. And I can also put in a number of BTU per hour that we might want for heating and cooling for those spaces. So if I come into this section, you can see here's my space. Oop, come here. There we go. Here's my space, and it's stopping at the ceiling, even though it's supposed to come all the way up to this 12'8" height at the roof. So what I typically do at this point is I'll come into my architectural model, go into a 3D view, window the whole works, just select my ceilings, say OK, turn off my room bounding, save it, go back in, go to Manage Links, select my architectural model, reload, say OK, and now my space goes all the way up, and I have a volume, it's up here, of 4,900 cubic feet instead of that 3,100 that we had earlier. So if I come down into, I've just set up a view with all of my information visible. I've got light fixtures, I've got air terminals, I've got my receptacles, dedicated and otherwise, all placed within my space. If I select my space, again, you'll notice that I have 0 foot candles. That's because my photometrics are looking at a generic IES file. So if I change that to, let's call it a 2x4 2 lamp, say OK, and apply. Now if I look at my space, I have an average of 49 foot candles at 2'6". Also, under this lighting calculation luminaire plane, it knows that the lowest light fixture in the space is at 8 feet. So it's going to take and calculate that estimated illumination at a distance of 5'6". So next, what I want to do is show you some schedules. A quick airflow schedule for the space, and I'm only showing the one space that I actually have in the project currently. It's reading the 2 diffusers that I have in place, what they are, and we have an actual and the embedded air terminal schedule airflow below it. So we can see I've got 150 here, and if I wanted to go 1 CFM per square foot, maybe I'd bump this up to 190 and 190, and that actual is going to bump up a little bit for me. The calculated would come in from my train trace GBXML, and then I would get a percentage difference between what's actual and what's computed. And then I don't have any return airflow in here yet, so my pressure check, I've got 380 CFM positive. And if you're ever curious about, well, is that an interior perimeter or perimeter diffuser, you can highlight the diffuser and just say highlight and model, and it'll immediately take us to that particular diffuser. So we can tell it, okay, that one gets a little bit extra because it's on the outside. Really good for, finding your linear slots and internal diffusers. So next, I've got, I just created a simple light fixture schedule, light fixtures with my space number, my ID mark, my type mark, apparent power and load, and a couple other things that get hidden out. And here we've got our space, the individual settings for our power, and then a total at the bottom. So we can set this up and use this, identifying each individual space with each light fixture within it to kind of come up with a complete and total load. Next is just a straight up space schedule that I'm going to look at as far as what's my area, what's my unbounded height, and what's my actual CFM. So if we had that ceiling bounding, that would show us that 3100. But we can also use this to change our offset if we wanted to come down 1 foot from the roof or what have you. Then it'll automatically update our volume, which will affect our calculations. And we also are scheduling the architectural links actual room information. So we can use this as a check to make sure we have the right information. Whenever we get an update from the architect, if they've shuffled some room names and numbers around, we can either come in here and double check if anything's different, or what I like to do is just run the space naming utility as soon as I get that new architectural model. So we can either go up to our roof level, as we're doing now, or if you happen to push it up a little bit further, you'll see that we are still being bounded by either the roof or the floor that the space is going to run into. So this does give us a really accurate volume, and then once we export that out to trace, then we can put in that plenum offset in order to make that accurate and get your plenum loads. So I can add a zone, and I'm going to add that zone there, finish editing, occupy area, and down here for this zone I can pick up the service type. What is it going to be? Is it central heating, radiant convection, VAV, single duct or dual duct? Do we have a coil bypass? And then our cooling information. Here's where we'd find our set points and humidification control. Same with heating. We have our set points and humidification. And then here's where we'd put that outdoor air information. Fudge this to be 0.083. And I'm going to double check this. 900. Let's select my zone. I want to make sure I have that space included, because it didn't seem to be picking up any of the information. Okay. It's live, folks. Alright, so I'm going to try and run heating and cooling calculation on just that space. Here we can set our building type to be either office or whatever we need it to be. We can define our location either by map. Are we doing new construction, sliver space? We can look under details. We have our zone 1 with the office. We have zone 2 in there as well. Okay. Calculate it out. Now I've got my building type, my peak, cooling load, heating, all that information. Here's my zone 1 summary along with all the spaces that are located in there. So this actually does get pretty close with giving our how much load do we get by infiltration and by ventilation due to that outdoor air information. And that's really all there is to it. Now if I go back to my space and scroll down, we'll notice that we have calculated heating and cooling loads. And if I go back to my airflow summary, this space should be getting 623 CFM. And again, that's based upon all 4 sides not having another space on the other side of it. So it's going to consider that to be, all 4 of those walls will be considered exterior walls. And that's why we're quite a bit higher than what we might regularly anticipate. So from here, I know that I should probably be somewhere close to 623 CFM. So bump that up. Oop, wrong one. 310. There we go. So now I'm pretty close. I'm pretty happy, and I can just quickly do that to my entire project. Just looking at my calculated CFM and my actual CFM. If I go back to my light fixtures, those are all showing up. Got all my loads in here, my light fixtures, computer. So that's really about it. Use them to help your design. So if there are any questions, if not, you can have a good afternoon.